In this video, we are going to look at simplifying radical expressions. Radical expressions are expressions that involve roots, and in this course, we're really going to focus on square roots. The first concept we're going to use a lot throughout this idea is this concept of a perfect square. A perfect square is a whole number that has a whole number square root. So the square root of 16 is 4, therefore 16 is a perfect square. The square root of 25 is 5, therefore 25 is also a perfect square. Most whole numbers are not perfect squares. So for example, 20 doesn't have a whole number square root. 4 times 4 is 16, too small. 5 times 5 is 25, too big. So the square root of 20 is what we call an irrational number. The square root of 20 is a decimal that goes on forever and never repeats. 4.47, and then it goes on forever. So if we use this in our solution, the best we can do is have an approximate answer. It's approximate because at some point I've had to round this decimal. So it's not an exact answer. So what we're going to talk about today is how can I get an exact answer? How can I simplify this root into an exact answer in simplified form? So let's keep looking at root 20. Now, root 20, we can break it apart and we can rewrite it as the product of root 4 and root 5. Why do I want to do that? Well, 4 is a perfect square because root 4 is just 2. So root 20 is the same as root 4 root 5, which is the same as 2 root 5, which is what's called simplified form. This is an exact answer, and in a lot of ways it's a more helpful and useful way to write square root 20 than 4.7 blah, blah, blah forever. How do we do that? What am I thinking about as I do this? So let's pick another example. So let's look at root 45. So I want to factor or break apart this into a product of 2 square roots. But what I need is one of these roots to be a perfect square. So what I'm trying to do is I'm trying to pull out perfect square factors from the radicand, which is the number under the square root. So for example, I could break 45 into root 3 root 15, but that's not going to help me. 3 and 15 aren't perfect squares. I'm not getting anything simpler. But I could factor root 45 as root 9 root 5, which is helpful because root 9 is just equal to 3, and so the simplified form would be 3 root 5. I can't get this any simpler. I can't get this any more exact because I can't pull out any more perfect square factors from 5. So as we work with radicals, we're constantly searching for these perfect square factors. So if we have kind of a list of our perfect squares, 1 times 1, 2 times 2, 3 times 3, we're constantly looking for these factors to pull out of our expressions. And there really aren't that many of these under 100 or under 150. So we're always looking for, can I break apart my radicand into a product of 2 numbers, one of which is a perfect square? So one more example, can I simplify 3 root 50? 3 is already a whole number. How can I express root 50 as a product where one of my factors is a perfect square? So I've got root 25 times root 2. So a simpler way to write 3 root 50 is 3 times root 25 times root 2. What is root 25? It's just 5. So I have 3 times 5 is 15. 15 root 2 is my simplified radical, or my radical in exact form. So that's all there is to simplifying radicals. We can use this to simplify some more complex expressions using kind of our standard rules of addition and multiplication. So for example, I can only add radicals if they are alike. So 2 root 3 is some irrational number, but if I have 2 of them and then I add 3 more, well, in total I've got 5 root 3s, or 5 times root 3. Root 3 is some sort of irrational decimal, goes on forever, but I can still collect them together. So I can collect radicals if they are alike. I can't collect radicals if they're not alike. Root 2 is some kind of inscrutably long, unrepeating decimal number, and it's different than root 5, which is just a completely different irrational number that goes on forever. I can't simplify this expression. So I can't add things together unless they have the same radical, unless they're like radicals. It's pretty similar to adding like terms. I can add 2x and 3x, but I can't add negative 5x and y, for example. So radicals are going to work similarly. I can only add them if they are alike. I can always multiply expressions together. So for example, I could have 3 root 2 multiplied by 5 root 6. And the way we're going to do this is I can, of course, multiply 3 times 5 to make 15. I multiply my whole numbers. And then I can also multiply my roots. Root 2 times root 6 will be the root of 12. I multiply my whole numbers first, then I multiply my radicals. And now I can simplify. I can break root 12 into root 4 root 3, because 4 is that perfect square. Root 4 is just 2. And now to finish my simplification, 15 times 2 is 30, and I have 30 times root 3. So 30 times root 3 is the answer to this multiplication problem. So I can multiply radicals in the same way, just doing my whole numbers first and then my roots. And this can extend even further. And again, we're kind of using the same patterns of multiplication. So for example, let's do 3 plus 2 root 5 multiplied by 1 minus 7 root 5. And this looks very similar to how we always multiply binomials. I have 2 terms and 2 terms. So I'm going to FOIL. I'm going to do first times first. 3 times 1 is 3. 3 times negative 7 root 5 is going to be negative 3 times 7 is 21, and I still have my root 5. So I'm just doing whole number times whole number, root times root. Then I'm going to do inside. 2 times 1 is 2, and I have a root 5. And then my final is 2 root 5 times negative 7 root 5, positive times negative, negative. 2 times 7 is 14. Root 5 times root 5, I can do the multiplication under the square root sign, and it's root 25. So root 25 simplifies to 5. So I'm left with 3 minus 21 root 5 plus 2 root 5 minus 14 times 5 is just the whole number 70. And then I can collect like terms. I can only collect like terms of the same radical. I can collect 3 and negative 70. That's just negative 67. And then how many root 5s do I have left? Well, I've got negative 21 plus 2, so I have negative 19 root 5. So the pattern of what we're doing, the way this feels, is really similar to doing 3 plus 2x, 1 minus 7x. It's almost just like treating what's under the root as a variable. So we're kind of using the same steps. I'm doing FOIL. I'm collecting what I can. X times x is x squared, just like root 5 times root 5 is root 25. It's a little bit of an overview on how we can simplify radicals, how we can add them, multiply them, distribute them. If you have any questions, please let me know. Okay, thanks for watching.